second PV Magazine Quality Roundtable here in Taiwan. Actually, it's our 12th Roundtable, Quality Roundtable worldwide. We are now on 5 continents.
And the particularity in Taiwan is that it has, on the one hand, a very strong upstream focus. It has strong manufacturing companies, and on the other hand, it has also a very rapidly developing downstream market. So there is a good outlook for a growing market, which also makes the manufacturers going downstream. They are doing EPC business, they are developing projects, and here at the Quality Roundtable we are discussing the topics which really affect the whole value chain. One of these topics is LID, light-induced degradation, with mono PERC modules, and one of the questions is whether manufacturers can control it, and when it's possible to control it, why maybe not all manufacturers do control it.
I think they do control, but some of them they do not do enough because the equipment's there and technology is there, but for some reason, for example, it will influence their production capacity, so they just do not do it enough.
Well, LID was what was known under LID for many, many years, since 1973, was the boron oxygen defect. And the lead ID defect, which especially happens at elevated temperatures, is due to something else that's not related to the boron oxygen defect, and that is summarized as lead ID. Both effects summarize to an overall degradation, and you have to reduce this overall degradation.
Unfortunately, the measures to tackle these different effects, to mitigate the risk, they partly counteract. To mitigate LETID, wafer producers have to reduce hydrogen content in the wafers. To mitigate LID in the cell production, exactly this hydrogen is needed.
Yes, it is possible to mitigate lead ID with the processes you apply during cell processing, and reduce boron oxygen LID losses with our tool as well. And that is due to the very high process flexibility that we have with our tool. We are using laser illumination that provides very high illumination intensities, and therefore we can have ultra-fast regeneration within seconds, but as well have a wide process window, so we can deal with the reduced hydrogen content in the cells as well, and still do very good boron oxygen regeneration that would work in combination with lead ID mitigation during the processes as well. So it is possible to have both at the same time, to reduce both the LID and the lead ID.
What do you recommend investors?
Well, I think investors, they should first get aware of this question, this problem, and also do some quality control before the installation and also after installation. Then you can find a problem earlier. Then you know how to deal with that.
Is there a method which you recommend to do the quality control?
Yeah, before the installation you make some, for example, EL test or even IV test, that's good. And after installation, after 1 month, you do the EL again, then you will see there's PID or not. Then if the situation is serious, then you send some modules to the third party to make the measurement, and you can claim for some compensation. I think that would be a good protection to the investors.
There's a huge potential for floating PV in Taiwan, and also many manufacturers are vertically integrating, are doing floating PV projects in Taiwan. So of course there's a lot of discussion going on how you can do that with high quality, which standards do you need, and what components do you need.
For this kind of environmental stresses, it requires some special requirement for battery, like it requires the battery that can be very have superior durability to UV and very strong mechanical strength and superior corrosion and chemical resistance. So at this point, So the Tesla-based backsheet can be the best choice. So for the floating PV. And on the other hand, some people may want to compare with glass module. But for glass, it have some mechanical issues because it's very brittle and it's have some dynamic load issue. So I think the polymer-based backsheet, Tesla-based backsheet is the best choice. As you mentioned, like for the testing standard about floating PV, so I first want to introduce the IC standard programs. In IC standard committee, so people talk a lot about the testing method, modification, upgrade. So the one change is that people want to increase the UV dosage. So that happened in some new IC standard version like IC 61730 and even other like IC 72892. So people want to try to increase the UV dosage to the backsheet material, to the module.
And is this enough?
It's not enough, but people realize that it's really need to improve compared with the old version.
I mean, Tesla is a material which is provided by your company, DuPont. Let's say as investor, if I want to make sure, let's say I compare it also with different backsheets, maybe what tests do you recommend for the investor to make sure or to also see whether backsheet fails or does not fail for floating PV?
So for floating PV, if we consider the testing method like increasing UV and increasing thermal cycle and increase the dynamic load testing, Tesla is still maybe the best or even the only one that can pass all of these upgrade requirements. For example, like PVDF based backsheet have some poor mechanical issues and have very brittle in TD direction. And for other non-fluorine based backsheet, durability is the issue. It's very poor resistant to UV. So this can so Tesla is best and it can pass the upgraded testing requirement. So people call like sequential aging test or combined aging test. That means several different stresses that are tested in the same sequence, in the same module.
You mentioned that it depends on the fluoride, which is in the Tesla, as I understand. How is it with? I mean, there's also the discussion going on with the water quality because sometimes it's drinking water where the installations are. Are there tests that works well? Has it to be tested whether it works well?
So usually the module is not directly contact with the water. So this is not maybe the most important issue for floating PV. So and for Tesla-based backsheet, they have very good durability. So you can sustain in the field for more than 20-30 years. So it's not the case that can possibly to impact the water quality.
Light-induced degradation and floating PV are really two very important and relevant topics for photovoltaics in Taiwan. I'm Michael Fuß of PV Magazine from the 12th PV Magazine Quality Roundtable in Taipei.